Hello guys, we are today going to be doing our video on a special rule today. So we are going to be doing it on the first law of Phat. Okay, is my camera a bit fuzzy? Hold up. There. It's still kind of fuzzy. Alright. The first law of Phat is also known as Zeng's Theorem, if I can spell that right. I can never spell theorem correctly. But anyway, this law states that the question number always has some relation with the answer to the problem. So let's say your problem is number 4 and the answer is 8, or the answer is 12. 4 times 2 is 12. That's the relation. And also, third times the charm. These two sentences correlate with each other to form Zeng's Theorem. And if you don't understand third times the charm, we'll finish watching the video. So now I wrote on the back some math club stuff, and there's a Sharpie's gonna bleed through. But anyways, sticking my hand is like what? Anyways, what is the value of the following? First off, Zeng's theorem, we notice that the problem number is 1. So 1 has to do something with solving the problem. So if we look here, this is equal to 4, that is equal to 4. So we can set each one of these as a big giant 4. And now third time's always a charm. We see that we have 5 4s. Third time's a charm, we have 5 4s, gives us 15. Now, we did the 4, so that we're gonna have to add 4 to that, 19. But look, the problem number is 1, so adding 1 gives us the grand total of 20. And that's the answer to number 1. Number 2, 18 is divided by the whole number n, the remainder is 4. This is true for how many different values of n? So first up, applying the first law of Phat, we see number 2. And we're like, this is a trick problem. Applying the law of Phat. Oh, whoa, that's a bit off. The answer is just 2. And you're saying, well, how does it not do anything with 18 or 4? Well, this is the proof here. So 18 is that number there. So we don't even have to look at anything else. Using the third times the charm, divide 3 is 6. And now we have the remainder is 4, so we can subtract 4 from that. There is your proof. 2 both ways. This is just a faster way of solving it. 3. Amy has 4 more quarters than dimes. The total value of all of quarters and dimes is $5.20. How many dimes does Amy have? And if we look at this, we notice that the problem number is 3. So we're saying this is a really special problem because the third times the charm is already in the question number. So we just look at this, we see that $5.20 is such a big value, and just like decimals, no one likes decimals, so we can just ignore this. We don't need this to solve the problem. Okay? Now, the problem number is 3, which is also third times the charm. And then we see this number 4, so we multiply this by 4, and we get 12 as our answer. Number 4, as shown, a square of area 100 is split into 4 separate regions, A, B, C, D. Regions B, C are squares, blah, blah, blah. No one needs to read. Our question number is 4. So now we see 100 square centimeters. So how in the world are we gonna solve this problem? And looking at this, you're like, how can I apply the law of Phat? 4 doesn't seem to go anywhere with this. Well, here is my solution. So, first off, if we don't know where to go, just write the problem number and just write the third times the charm, and we get 12. And then you can just keep doing this. Just add more of the problem number. Just add that, let's say 2 times. I don't know, as many times you want. But then let's add it 2 times for this case, and then we get 20. And we still have to use this number somewhere. So let's just use 100 minus 20. And we get 80, and that's our answer. See, that's a tricky case of the first law of Phat. You have to know when to apply it. So our answer is 80. Next one. Question 5. So we see this is 5 and we're doing with fractions. So 5 is either the denominator or the numerator. And it says find the greater of these two fractions. So we need to find what the denominator is. So do we know if the denominator is 5? So 56 is 7 times 8, so we can just use 8 as a denominator because it's a random number we found. So the rule of Phat says whatever's left has to be the numerator. It has to be in the problem. So now we have 5/8 as our answer. And here, this is another special case. We didn't need the third times the charm in this. We only needed that number because it's already directly in here. See, 7 and 8 here are next to each other. So we will learn later that median numbers are very important. But right now, 5/8 is our answer. Number 6. Whoever her name is, Maisie, has 3 times as many CDs as Ken. And we see 3 third times the charm. Ken has twice as many CDs as Joe. Joe has more than 10 CDs. Now we see the problem number 6. So let's just write 6. Okay, and now looking at this, we see 3, and then we see twice, which represents 2. So 3 times 2 is 6. If we put these two 6's together, laws of Phat, we have applied this. The 3 here represents the problem number and the rule of 3. Then Ken, we have to have that number 2. And then the number 10 is actually like really kind of unimportant there, so we'll just cross it out because no one needs to know that Joe has more than 10 CDs. Like, whoever has more than 10 CDs nowadays, like, no one has that. And same thing up here. Like, no one has $5.20. Everyone has like $1 million, like Anton. Anyways, this is our stuff. If we put the two 60s together, we get 66 as our answer. Number 7. The cars of a circular Ferris wheel are equally spaced around the wheel's circumference. So instantly we see that this is 7, and let's look around. So we see number 1, we see number 14, and we see number 30. So what are we going to do here? First off, let's just subtract these two. So we get 30 minus 14 equals 16. And we're also going to write the question number. So now we need to know what to do with this. So what we're going to do is, let's just add, we see the number 1. Let's just add 1. How many times you want. And then we can subtract a 1 too. And you see this makes a giant 1. So this is nothing. Anyways, that was just fun because giant ones are cool. So now we have 8 because we can do anything we want. And now, if we take this number and divide it by 8, we get 2. Because 16 divided by 8 is 2, if you didn't know. Now, if you use the rule or the law of Phat, first law of Phat, we can get 6. 3 times this 2 is equal to 6. Because the rule of 3, third times the charm. 3 times 2 is 6. So now what are we going to do with this? So we see this 2 here, we've only used it once, why not use it again? Now we get 4. So what do we have to do with this 4? This 4 is like lonely over here, so let's multiply it by the 8. We get 32. Working as a team, 8 mathletes can solve 20 problems in 10 minutes. How many mathletes are needed to solve 30 problems? So this problem is a trick problem. First, you look at it, then you realize how many mathletes are needed. That's a trick problem. You only need 2 mathletes. And you're like, huh? How is that the answer? And my reasoning is this. We only need Justin and Anthony. You don't even need the first rule of Phat. This question is so easy, you don't need the first law of Phat. Let's go on. 9. These points all lay on one line. How many different triangles can be used of any 3 of these points? So let's just count the points. 1, 2, 3, 4, 5, 6, 7. So there's 7 points, and we need something. So why not use the rule, the 3rd times the charm rule? And well, now we're at it. I don't think 10 is the correct answer. Let's do that. Multiply by 3. We get 30. That's our answer. Simple. What is the greatest counting number that divides all these and leaves the same remainder in each case? So here we see that this is 10, so we're going to write that down. And I don't know how to subtract, so I don't know what the subtraction is. So let's use a calculator to subtract it. Okay, alright. Let's subtract. Okay, so what are the numbers? 25 and 17. So what's 25 minus 17? Our calculator says it's 8. So let's write this down. So we really need to know this. But since I'm so smart, I know what this is, and this is 16. So if you see 16 minus 8 is just 8. And you're saying, wow, we see 2 8s. What does that mean? Well, if we see 2 8s, then the answer is 8. But you're saying, what about this number? This number is actually used in the freaking fan, bro. This number is used in the proof. So what you're saying, proof, bro? I'm like, yeah, proof. So 10 minus the rule of 3 is 7. And then now 3 times 3, because rule of 3 is 9. And now up there I said the median is an important number. And of course 8 is the median of 7 and 9. This is the ultimate proof of solving this problem. Okay? We take the median between 2 numbers. That's also the answer. So if anywhere here you can find the median of 2 answers, then that's the answer. So for example, let's take number 2 here. So if you want a bigger proof than this, you can also have, we can start out with the rule of 3. And we can also start out with this 4 here. Now if we subtract 4 and 3, we get 1. Now we write this 1 over here and we say, oh my gosh, what's the median? 2. Boom. 3 ways of solving that problem. And therefore, I present to you the first law of Phat, Zeng's Theorem. The question number always has relation with the answer, and 3rd time's the charm. Peace out, y'all.